Good evening children, welcome to Yupp Master, the school foundation program, and it is a great opportunity for you students to enjoy the online classes through Yupp Master. So, I advise you to please download the app, get in connected with the online classes that are going for the foundation program. Of course, foundation program is very important as far as the IIT JEE and NEET examinations are concerned. So, you people can enjoy the online classes through the Yupp Master. So, we are here to give you the maximum knowledge with respect to the given subject. So, please enjoy the classes, not only yourself, please advise your friends and well-wishers to download the app so that they can also enjoy these online classes. So, I am your chemistry teacher, Dr. Sripad Rao. So, I am going to teach you chemistry, what we have learned in the first class regarding the chemistry and its importance we have gone through, and let us today focus on the syllabus what we are going to discuss in class 6th foundation program. Okay. So, the first topic in this case is the nature of chemistry. So, we are going to discuss the different terminology that is going to be used in the case of chemistry, language of chemistry, the ion representation, atom representation, how the ions are represented. All these things are going to be discussed under this particular topic, the language of chemistry. And then we are going to discuss some basic concepts in chemistry, the developments that took place in order to get the clear idea of nature with respect to the chemical reactions or chemical concepts. So, that can be discussed under this particular topic, basic concepts of chemistry. Okay. And then we have after that the atomic structure. So, the fundamental particles were discovered like electron, proton and neutron. So, electron, proton and neutron, how they are arranged in the atom and how the scientists were thought in the initial stages, how the developments took place and how the final what we are using today about the atom structure was discussed in this particular topic. Of course, we are going to give you the basic information, and based on that we are going to build up the concepts. Do not worry, we are here to clarify all your doubts. We will give you the concepts or the theories in a clear and neat fashion so that you can enjoy these classes. Okay. And next the chemical bonding is the chapter. So, there how the chemical bonds are going to form, what is the reason for forming the chemical bonds, different types of chemical bonds, examples, their properties, all these things we are going to discuss under this particular topic, chemical bonding. Okay. And then we have acid, bases and salts. This is very important topic as far as the competitive examinations are concerned. So, here we are going to discuss what is an acid, what is a base and what is salt. And again, see, every theory will not come as a in one day, right. So, the theories will be developed years by year with a different scientists. So, with the view of different scientists, the theories were proposed. So, we are going to discuss the different theories proposed for acids, bases and salts in this particular topic. Okay. Then we have allotropy of carbon, because carbon we are going to deal in a separate chapter as separate topic as organic chemistry. So, there we require the information about the carbon. So, we are going to give you the concepts of carbon initial stage, like in this 6th class foundation program, the allotropy of carbon was introduced, so that you can identify are the different allotropes of carbon. What is an allotrope, that basic definition, which elements in the periodic table are having allotropies, etc. All these things we are going to discuss in this particular topic. Main focus is the carbon allotropy forms. Okay. Right. The transformation of substances, how I think you people have observed. So, whenever we go for converting the milk into curd, how the milk is converted into curd, what is the change that is taking place for the conversion of milk into the curd. So, I think you have an idea, but also you have gotten a question mark in your mind that how the milk is converted into curd. So, similarly, chemistry will have an idea, the question in their mind how the transformation takes place. How the food what we are taking converting into energy, how it is converting, what is the reason. So, the transformations generally we are going to take in this particular topic, the transformation of substances. The basic need for the existence of life on the earth is water and as well as air. So, we are going to discuss the water and air concepts as well. Here we are going to look into the what are the pollution factors, how many water bodies are present, how the components of air got polluted, the causes of pollution as well as the prevention. Prevention is required, okay, we have to avoid pollution. So, in order to avoid pollution, we should take some prevention measurements. So, there we are going to discuss about these concepts. Okay. Lastly, we are going to look into the apparatus in chemical laboratory. So, generally whenever we say science, science means it is an experimental concept. Okay. So, experimental concept means you should carry out the experiment, and from that experiment whatever information you are going to get, you have to analyze it for the observation. Okay. So, that for that purpose we require a laboratory. Laboratory is a room where the experiments will be carried out. Similarly, in the chemistry we have a laboratory where we are going to carry out the chemical reactions. For carrying out the chemical reaction, we require apparatus. Similarly, in order to cook food, in order to prepare some beautiful dishes, beautiful curries, what your mother do? Your mother generally use the utensils, right? Similarly, in order to look at the chemical reactions that are taking place at the laboratory, how the chemical transformations occur, we require some apparatus. So, the different apparatus that we are going to use, all these things will be discussed under this particular topic. So, in order to prepare food, we require utensils. In the similar way, in order to carry out a chemical reaction, we require some bowls. So, the bowls generally we call it as apparatus in the chemistry laboratory or chemical terminology. Okay. All these things we are going to discuss in this particular topic. So, these are the 11 topics which we are going to cover throughout the year for the foundation program for class 6th. I think we are going to enjoy the classes with respect to all these topics. Okay. Right. Today, let us start the first concept, that is nature of chemistry. Okay. So, let us move on to that one. So, in that particular topic, what are the other concepts that are covered? So, here we are going to discuss about the physical classification of matter, how the matter is classified. Again, a question may arise in your mind, what is matter, sir? What is matter? How to define it? Can you give an example? Yes. Let us first look into the matter, what is matter and how we can classify the matter, and then we look into the other concepts. Okay. Right. Matter is anything which is going to occupy some space and which is going to possess some mass. Okay. What is matter? Matter is anything, okay, matter, it can be anything which possess mass, which has mass, okay, which has weight. Mass means here weight, which has weight, and when you keep it in any area, it is going to occupy some volume, okay, which is going to occupy some space. Matter is anything which has weight, okay, and which is going to occupy some space. Best example of matter is myself. I am a matter. Yourself, you are a matter. Why? I have weight. I weigh around 70 kgs. So, my mass is 70 kg, and if you put me on the surface or the ground, I am going to occupy some space. So, I am a matter, simple. So, you are a matter. I think your weight is around 25, 20, 30 kgs, right? So, you are going to occupy some space. When you sit in the chair space is occupied, right? Chair, for example, is a matter. It has mass and it is going to occupy some space. The textbooks that you are using, the textbook going to have some mass, some weight, right? So, it is going, when you keep it on the table, what happens? It is going to occupy some space over there. So, it is a matter. The pen that we are using for writing purpose, pen has some weight, okay. When you keep it on the table, what happens? It is going to occupy some space. So, pen is a matter. So, anything in the nature which has mass and which is going to occupy some space is generally taken as matter. So, water for example, if you take liquid, water has mass, right? If you take 1 glass of water and 2 glasses of water, 2 glasses of water will be very heavier compared to the 1 glass of water. Automatically, water has weight, okay. And when you pour the water into any bowl, what happens? It is going to occupy the volume of the bowl. So, it is occupying space. So, water is matter, simple. Air, the air that is surrounding us. We know air is a composition of all the gases like nitrogen gas, oxygen gas, carbon dioxide gas, water vapor gas, etc. Right. So, when you take air into a room, automatically what happens? Air will have a weight. A question may arise in your mind now. Does air has weight? Yes. If you fill the balloon, for example, let me take a balloon, small balloon, and fill it with air, and take one more balloon, fill little more amount of air in it, okay, and tie these two to a stick. Automatically when you take that balance, what happens? The balloon which is having more amount of air will go down compared with the other balloon. So, what does it indicate? Air has weight, air has mass. So, air has mass, okay, and it is going to occupy. For example, if I make the air to come into this room, what happens? It is going to occupy the total room, right? So, it is going to occupy the total space in the room. So, it is has a mass and it is going to occupy the space. So, air is matter. So, anything in the nature which is going to have the mass as well as which is going to occupy some space is said to be matter, simple thing. Okay. So, this thing you have to keep it in mind, whichever component you take in the nature, if it has mass and it is going to occupy some space, that is categorized as matter. So, best examples are water is best example, air is a best example, book is a best example, pen is a best example, myself best example, yourself, human beings, animals, okay, the bacteria, virus, everything is comes under matter. So, all these things are coming to be matter, but what is not matter? For example, if you get angry, what happens? Angry, when your friend starts irritating you, what happens? You get angry, right? So, what is angry? Angry is a feeling, it does not have a mass, it does not have a volume, it does not occupy any volume, does not possess any weight. So, angry cannot be taken as matter. Hunger, so as soon as 12 o'clock bell ring bells, what happens? Lunch time, you will get angry. So, the rats start moving here and there in your stomach, automatically what happens? You feel hungry. So, hungry is a feeling, it is not a matter, okay. So, feelings are different. Happy, when you see your favorite movie, hero movie, okay, automatically what do you get? You get happy. So, happy is a feeling, it is not a matter. So, matter is that thing which is going to possess some mass and which is going to occupy some space. So, it should have mass and it should occupy some space, space in the sense volume here, okay, volume, some space, some area it has to occupy, it should have some weight and it should occupy some area. So, that is said to be matter. So, I think by this time you got a clear idea about matter, what is matter and what is not. Feelings are not matters, okay. Anything which has mass and occupying some volume is matter, right, right. So, how we can identify or how we can classify the matter? As we have discussed the solid particle, for example, sugar if you take, sugar is a matter. How? Sugar has some weight, sugar crystals will have some weight and it is going to occupy some space. Salt if you take, common salt, table salt, what we use in our home for preparing the food, okay. Salt is going to has mass, okay. If you take, how you are going to buy the salt and sugar from a market, supermarket? Generally we buy in terms of kilograms or grams, right. So, it has weight, and when you take that packet and keep it in your home, what happens? It is going to occupy some space. So, salt is a matter, sugar is a matter, right. So, sugar, the matter can be a solid, okay. Similarly, water, as I said, water is going to have some mass and it is going to occupy some space. So, water can be, that is liquid, is also matter. And similarly, air I have taken as an example, it is occupying some volume and it is going to possess some mass. So, what happens? Air can also be considered as a matter, okay. So, air, that is gas is also a matter. So, when you look at the classification of matter, how can we classify the matter? So, we can classify the matter as in a different phases. This is called the general physical classification. So, based on the physical state of the matter, we can classify the matter into 5 categories, okay. But of course, we generally focus on the 3 classifications of matter, that is solid, liquid and then we have the gas, okay. So, matter can be classified as solid, liquid as well as gas, okay. And we also have 2 more states of matter, one is plasma. Of course, we are going to discuss about all these different physical classifications of matter. Of course, we also come across the plasma, okay. And the last one, but the not least is the Bose-Einstein condensate. Of course, these are recently included classification of matter. generally what we focus is with respect to the solid, liquid and gas. Generally we come across these three physical states of matter most of the times, but of course under special conditions only we come across the plasma as well as Bose-Einstein condensate. Do not worry about the classification, we are going to look into the each and every classification of matter with respect to the physical nature, and then we will discuss, we will compare the properties of these matters as well. Okay? Right. Let us focus on the other concepts of matter. First of all, let us look at the solids. So, when you look at the solid, have you observed any time the crystalline nature of sugar? Have you any time taken one crystal of sugar? Have you observed the structure of sugar? No, I think, right? So, if you say yes, yeah, very well and good. If you say no, please now go to the kitchen, take out one crystal of sugar and observe the shape of that crystal. You can clearly observe the shape. It's a small one, small piece, but you can clearly observe the shape there. Similarly, have you observed the crystalline form of salt? Salt, the small granule, if you take it into hand and just observe how it looks. Okay, you can easily understand how the things are going to be, solid things. Wooden piece, for example, a chair made up of wooden, a table made up of wooden, or a sofa set made up of wooden. If you observe, you can clearly see the particles are tightly packed over there. In the case of sugar crystal also, if you take one crystal, the total particles are slightly packed and it is giving that particular one crystalline component. Okay. Similarly, if you take salt, salt also has fine crystalline structure. So, the crystalline structure can be easily observed for the solids. Okay. So, let us give you a small concept about the solids. If you observe here, solids will have a definite shape as well as definite volume. Shape is possible, volume is also possible. When I take the solid and I will throw it on the table, what happens? It will fall and it will settle there. It is going to occupy some space. Okay. And if you observe the arrangement of the atoms, in an orderly fashion the arrangement takes place. And when you look at the atoms, the particles that are present in the matter, they are going to be very close to one another. The particles are very close within the matter, that is solid form. Okay. So, you can just observe one more time that the solids will have definite shape as well as definite volume. If I try to pour this solid onto a table, what happens? It will settle down on the table without any disturbance, it will not flow. Why it is not flowing? The particles are neatly arranged in an ordered fashion, and if you observe, the particles are very small and they are fixed in their position, they are not moving at all, and the particles are coming close to one another. And when you observe the space here, the intermolecular spaces are very small. Okay. So, when you look at the characteristics of matter, matter is going to have some mass and it is going to occupy some space. This is what we have seen that in the definition of matter. Okay. And when you observe the constant particles, the constant, when you look at the matter, matter is made up of very small particles, and these particles are separated from each other and they are going to have some intermolecular spaces between them. So, here the intermolecular spaces or interatomic or interparticle spaces, if you observe, interparticle space means the space that is available between the two particles. So, when two particles are taken, the space that is available is very small in the case of a solid. In case of a solid, the space between the particles is very small. Okay. So, that can be seen here. If you observe this picture, it is clearly showing that the particles are neatly arranged, they are orderly arranged. Okay. And when you observe, for example, if I take two particles and if I observe closely by using the microscope, ultra microscopes, you can observe the particles are separated from each other, and of course, a very small space is present between these particles, that we can clearly observe. Okay. Right. And when you look at the solid, the characteristics of solid, how we can characterize the solid. So, let us take the same arrangement of solid particles in a solid. For example, this is a matter, right? It is a solid pen. So, if I look into the internal structure of this particular matter, the components that are present, I will take it as a particle. So, every matter is made up of very small particles, very small particles. So, these small particles are arranged in a different fashion. In the case of solids, when you take solids, when you look at the solids, How the particles are arranged? Look at the arrangement neatly. I think you people also stand in a neat arrange lines in the morning session in the assembly, right? In the school, right? Every morning in a school assembly, students will stand in a particular rows and particular columns. The arrangement of the students in the particular column and lines are perfect. It's orderly arrangement generally takes place. But as soon as the assembly is over, what happens? You people will go into your classroom. So in that case, you move in a random fashion. So of course, the arrangement will be very different in that case. But when you observe the solids, in case of solid, when you take sugar crystal, whether it is a salt crystal. So in case of sugar crystal or salt crystal or a wooden piece, the atom or the particles of that solid are arranged in a neat fashion. Okay, they are arranged in a orderly way. So there is no disorder. So you can observe the layers also are arranged one by one, one by one. It's looking very symmetrical, looking beautiful, right? So when you observe this one, we can come across some properties. So based on this one, we can write some properties for solids. What are the characteristics of properties of solids? First one, if we observe, the molecules are closely packed together. How the molecules are arranged? For example, if you take sugar, sugar molecules are arranged in a closely packed together. What is the space that is present between the particles? If you observe here, the space is very small, you can clearly see. So when you observe a solid, in case of solids, whether it is atoms or molecules, they are closely packed. Closely packed means they are coming close to one another. The particles are coming close to one another and they are packing together. Okay. When they are coming close, what happens? The space that is present between the particles is very small. Okay. And the with very little empty space is present between the molecules. So within the molecules, very small space, empty space is present in case of solids. Okay. This is first characteristic property of solid. Second one, molecules cannot move freely. So if they are packing very close enough with one another, if you observe here, let me take this particle. Let me take this particle. Okay. So if I take this particle, can it move? It cannot move upward because adjacently we have one more particle. It cannot move downward because we have one more particle here. It cannot move to the right side or it cannot move to the left side. Why? The particle is surrounded or it is closely packed with other particles of the same solid. So in that case, what happens? Is there any free movement we can expect for the molecules? Molecules cannot move freely. Molecules cannot move freely. For example, if you are standing in a lift, let us say lift, okay, and if you are surrounded by 10 people around you within the lift, as soon as your floor is reached, what happens? You have to make them to give you way so that you can go out. Okay. So if they are tightly packed, can you move from the lift? No, it is not possible. Similarly, in this case also, since the particles in the solid are closely arranged, tightly packed with a very little empty space is present. So therefore the molecule cannot move. So it has to be in a constant position, no this way or that way. Okay, it has to be in a constant position. Molecules cannot move freely in case of solids. Otherwise, you can say that the particles present in the solid cannot move freely. Why they cannot move freely? Because the particles are closely arranged. They are arranging in a closely ordered fashion with very little space between the particles. So the molecules or the particles cannot move at all. So the movement is not possible then. Since the movement is not possible, so they will be in a ordered fashion. They are standing in ordered fashion, whether you take in a top to bottom or left to right, right to left, we can see clearly the ordered fashion. So because of this one, what happens? The solid particles, the solid matter going to possess definite shape. If you observe the crystalline sugar crystal, you can see the cubical arrangement, of the sugar crystal. So it will have a definite shape, the shape is possible for solid, okay. It is going to have shape, and we know when you throw it on the floor, what happens? It is going to occupy some space. You have a wooden piece at your home, let us say, okay, you have a wooden piece at your home. If you look at the wooden piece, it has a beautiful shape, right? okay, and when you throw it on the table, on the floor, what happens? It is going to occupy some space. So, solids will have definite shape, shape is possible, okay, and it will have a definite shape, and it also going to possess definite volume. Shape is present for the solids and also volume is also present, and that too a definite shape. You can have a clear shape. Look at the chair that you have at your home. Chair made up of plastic or chair made up of wooden chair or plastic chair. If you observe, you can see the how the particles are arranged. The rubber or the plastic is also taken as a solid component, okay. So, plastic chair also falls under the solid matter only, right. So, when you observe this plastic chair or the wooden chair, what happens? It has a definite shape. You have a chair shape, right, and it is going to possess some volume, it is going to occupy some volume. When you keep your chair in your home, it is going to occupy some space in the room, right. So, solids will have definite shape, definite volume. Why they have definite volume and definite shape? Because in the case of solid, the molecules or the particles cannot move. There is no movement for the particles. So, they are standing, they are sitting in a particular position like calmly without any disturbance, without any movements, okay. So, therefore, they are going to have definite shape and definite volume. Why the molecules are not moving? Because the molecules are closely packed. When they are closely packed with a very less space between the particles, what happens? Can we expect any movement? No. For example, if you are sitting in a class, 3-4 students are sitting in one bench. Is it possible for the student who is sitting in the middle to move here and there? No, he cannot move, because this side he has some more students and this side also he has some more students. So, it is not possible for him to move. So, similar way here also the particles cannot move because they are closely packed. Since they cannot move, they are going to have a definite shape and they are going to have a definite volume. So, solids will have definite shape, definite volume. This point you have to remember, students, okay. Of course, it is a easy thing, it is not that typical to remember, okay. You can easily remember. Once you observe the particle arrangement, you can clearly see. So, what are the examples? Rubber, salt, sugar, the powder. I think I have seen the wheat powder, java powder, ragi powder. So, all these are solids, okay. And the glass that you have used, seen for the wood, the window glasses, if we observe, they are also solids, okay. So, the solid components, the best examples you can observe: powder, any powder, rubber, salt and glass. So, all these are taken as an examples of solid. So, students, you can easily remember by looking into the arrangement of these particles. First observe this one, okay, right. So, here if you observe, the particles are closely packed, the particles cannot move at all, movement is not possible. Since movement is not possible, they are going to have definite shape and definite volume. So, the definite shape, definite volume of solids is because of the arrangement of particles. So, once you observe the arrangement of the particles, we can easily come across the shape as well as volume, okay. Best examples: the wooden made material, plastic made materials, are the rubber, salt, sugar, powder, glasses, okay, all these things. My goggles, okay, the pen that I am using is a solid, this one, remote that I am operating the slides, all are solids. So, you can easily observe the solids in our day to day life. Why their solids have a definite shape? This has a definite shape, you can observe, it is a rectangular in shape. Why? Because it is made in terms of rectangle and the particles present in it cannot move at all. If the particles are moving, will it remain in rectangular shape? No, simple, okay. So, here in case of solids, the particles are closely arranged. Since they are closely arranged, empty space is not present. If it is present also, very small empty space, very little empty space is present, and because of the very little empty space, the particle cannot move here and there. So, the movement is not possible. Since the movement is not possible, they are going to have definite shape, definite volume. So, students, you can easily remember the examples of solids and you can easily remember the 3 characteristic properties of solid. So, solids are the first physical classification of matter, okay. I think you have enjoyed the today's class. So, we are going to see some more concepts like liquid as well as gas, how the particles are arranged, what are the examples of the liquids and gases, how the plasma is going to be formed, and we even go for the differences between the solid, liquid and gases in the upcoming classes. I think today you have enjoyed this solid concept. We will see the liquid and gas in the next concept. Okay. Until then.